Okay, we're going to move on and talk about standard deviation here. All right, so standard deviation is going to measure the average distance of the observations from the mean. So we're going to talk about that in terms of the squared distances from the mean. So the way that we're going to calculate it is we're going to find the mean first, and then we're going to subtract from the mean, or vice versa, the individual data points. It doesn't matter which order you subtract them from, because when you square them, the difference is going to be, that square difference is going to be the same. So the mean minus x1, first data point, mean minus x2, yada yada through x sub n. We're going to sum those values, and then we're going to divide by n minus 1 when we're using a sample of a population, which is what we'll typically do. But when we have the overall population, we're going to use n. Okay. Unless I specify otherwise, assume that we're using sample of a population, not the entire population. So you're going to use n minus 1. But this is a distinguishing feature here, when to use n minus 1 versus n. But again, unless I specify otherwise, please use n minus 1 for this value. All right, so variance is going to be the standard deviation squared. It's basically the same value as the radicand, right, in that value that you create. So it's the sum of the square differences divided by n minus 1, not the square root of those values. All right, so we're going to find the mean value, the standard deviation of this, let's say, sample population of 5 values. So the first thing we want to do is we want to find the mean value. So we're going to add these together and then divide by 5. So the mean value is 75. Then we're going to take 75, subtract each of the data points, 75 minus 67, then square it. And then add 75 minus 72 and square it. And then add 75 minus 76 squared, plus 75 minus 76 squared, plus 75 minus 84 squared. And then we're going to sum these values. So this becomes my numerator, 156. And then I'm going to take my denominator. We're going to use n minus 1 again in this case. So I have 5. 5 minus 1 is 4. I'm going to divide 156 by 4. That's 39. That's my variance. And then I'm going to take the square root of this value. This is the standard deviation. That ends up being approximately 6.24. All right, for now you can round to the 100th, or just leave it as a square root of 39. So let's move on to your third classwork problem. I'm going to give you a stem and leaf plot. And this is a look at the presidential election and how electoral votes are allocated. So as you may or may not know, the presidential election is not determined by popular vote. It's determined by electoral votes. Each state has a different number of electoral votes. And so this is a list of all of the electoral votes based on the different states in the United States. And so what I want you to do is create a 5-number summary, box plot, determine the outliers, the mean, and the standard deviation for the data set. All right. So please copy this down, and then I am going to move on. Okay, let's move on. And again, you're going to submit this as classwork, so you're going to submit it to me in a way that I determined for you outside of this video. This brings us with numerical summaries with technology. I'm going to go briefly through this because I'm going to have a separate video on these, but I do want to call your attention to your ability to calculate the standard deviation, mean, quartile ranges on your calculator. So this goes through the process using both TI-84 and TI-89, how you enter the data. This is in your book, by the way. And then what it looks like on the back end for you. So you have number, mean, standard deviation. So this is 1/2 of the look at the spread, the distribution, then minimum, Q1, medium, Q3, and maximum for you to write a box plot. So please reference this in your textbook. You will need to be able to use your calculator fluently without reference for the AP exam. You should be able to get enough practice. I will go through these in a separate video, and I will give you a cheat sheet to work with as you do your homework. All right, so this brings us to our last issuance between choosing measures of center and spread. Basically, very simply, for the most part, if the median and the IQR, if the distribution is skewed right or left, then the median and IQR are usually better than the mean and standard deviation. If the distribution is roughly symmetric, then we're going to use the mean and standard deviation. And again, outliers will skew the data. So if there are strong outliers, then we want to move that analysis to median and IQR, which doesn't mean that mean and standard deviation cannot be a useful tool, but it might not be our first choice. Okay, so this brings us to the end of the video. I do have some additional classwork to do, but we'll do this in class when I see you. Thanks very much for joining in our discussion about describing quantitative data with numbers, and that brings us to the end of Chapter 1.